Hey, howdy, folks. It's Virtual Schmied here with you guys today, specifically talking about part 2, the symbol screen of the build and atom simulation. So what I'm mostly going to help with is number 1 right here, decoding this weird A, B, D, C symbol there using the build and atom simulation. So first, make sure that you are on the symbol screen, because what we're trying to match up is the symbol that A, B, C, D over here with the symbol that's on the screen here, and just figuring out which parts of that symbol are affected by which specific subatomic particles, protons, neutrons, or electrons. So that first one, the box in the middle, A, we know that to already be the element symbol. And I know that if I change the number of protons, it's going to change that element symbol. If it has 1 proton, it's hydrogen. If it has 2, it's helium. I can keep adding and keep changing that symbol. I'm just going to add in 3 of everything here to get myself started. So for A, I already know that's the element symbol. It's used to number protons, and how I determine that is just by looking at the atomic number on the periodic table. Let's look at box B then, the top right box. So up in that top right box, I see that right here. Right now it's +1. And right now I have 4 protons and 3 electrons. I'm going to throw in another electron. Now it's 0. Now it's -1. So it seems like electrons make that number get more negative. They make it go down the more electrons I add. And I'm just paying attention to this top right box right now. But if I add more protons, that number starts to go back up. That makes sense what we know about charges. Protons are positive, are going to send the charge up. Electrons are negative, going to send the charge down. So how do we determine that? We can just take protons minus electrons, and the particles used are protons and electrons to figure that out. And the term we use to describe that is just charge. If we wanted to be more specific, we could call it electric charge. Generally, we just call it charge. All right, let's look at box C then, that bottom left box. So right now it's 7. What's going to change it? So when I put neutrons in there, or when I take neutrons out, that bottom 7 doesn't change. So neutrons don't touch that bottom left number. Electrons don't seem to touch that bottom left number either. As I take electrons in or put them out, that 7 didn't change at all. But protons, work with me. If I throw in a proton, that bottom left number does change, because that bottom left number is the atomic number. So the particle used to determine this is just protons. And the number of protons identified. Honestly, the bottom left number is redundant. If you know the element, you know how many protons it has as it. You don't necessarily need the A and the C box, but we like to look at it that way when we do atomic and nuclear symbols so that we get all the information in there, especially when we start dealing with isotopes. All right, last box D, and this is this top left box here that I have to deal with. So again, I'm just going to mess with some of these subatomic particles and see what changes. Electrons don't seem to be doing anything again. They're changing that charge number, but they're not changing that top left number. It's stayed at 8. What if I take out a proton? Okay, it went down. So protons affect that top left number. I think neutrons also do as well. The more neutrons I add seem to be affecting that top left number. So that is protons and neutrons, and it seems like they just add together. I don't have to deal with any funky negatives there. So that is number of protons plus the number of neutrons. And usually what we call this is the mass number. You'll also just hear it called the atomic mass. And usually that's what I prefer to call it, is the atomic mass. I'm going to underline that one, actually. But you'll see both mass number and atomic mass. They're the exact same thing. When you see mass number, atomic mass, know that it's talking about protons plus neutrons. Alrighty, folks, that was a little bit of guidance here to help get you guys started. I think number 2, you can create a definition for these things based on what affects them, the protons, neutrons, or electrons, depending on what the symbol is. And then down here, I think you'll connect these dots to do these atomic symbols. So I'm going to go ahead and cut myself off now. This is Virtual Schmied.